Okay, so last class we did, I think, rain umbrella problems, right? So today we'll consider river man, or sometimes it is called river man problem or river boat problem. Woman also you can say if you want, no problem. First, let me give you the main theory, then we can solve some questions, and then we have some very good questions. Okay. So let's say this is your river and these are the two banks. First, understand this board you have to think horizontal. River doesn't flow this way, river flows this way. People do swimming this way, not like this. Understood? So don't think gravity is here. Don't think gravity is here. That we did in projectile motion. Okay, so please understand this is horizontal. Therefore, gravity will have no role. The flow is in this direction, the water flow is in this direction. Three important velocities we have. First one is velocity of water. This is velocity of river or water, they will say. Sometimes they say velocity of current, river current. Of course, it is with respect to ground. So somebody standing in the ground will see river flowing this way. Then we have velocity of man with respect to water. This is also called velocity of man in still water. And finally, if you add these two, you will get velocity of man with respect to ground. So this is velocity of man. Some people call it actual velocity. Actual matlab with respect to ground. How these three are related if they ask? That day I discussed with you. Velocity of man with respect to ground is what? Velocity of man with respect to water plus or minus? Plus velocity of water. When you write relative velocity, that time there is minus. And now I think you understood why this is called velocity of man in still water. Because if water was still, what will be this? 0. Then what will be this? Velocity of man. But in still water. For this to be this has to be still. But if water also moves, then ground people will see the man has this velocity. So how many velocity man has? You can say this, or not and, or it has this too. So when ground people will observe the man, what is his velocity, man's velocity from ground? Either you say this or this too. Don't say this. Understood or not? Either it has these two as components of this, or you think this is the man's velocity. Now let's say man starts from here at time 0. Let us call this x-axis and this one as y-axis. So it starts from origin. Now where it is swimming, that we don't know. So let's assume it is going in this direction. So this is velocity of man with respect to water. So in water, just like in bus, you may be walking perpendicular to the movement of the bus. Bus is going here, but you may be walking perpendicular. You may be walking sometimes parallel. Sometimes you may be walking opposite to the movement of the bus. So that is what? Your velocity in bus, matlab with respect to bus. So this is that velocity, not the velocity seen from ground. That is clear? If I go from this seat to this seat, then bus people will see I moved this way. Ground people will see I moved at some other angle, because bus is also going here. I am also going here. So resultant will be somewhere here. Understanding or not? So please be very clear what is this velocity. This is the velocity with which the man swims. Okay, his strokes are at angle theta with normal. This line is what I am going to call normal. Normal to whom? Normal to flow. Some people may give you angle with x-axis, matlab with the flow. That will be what? Theta plus 90. But I am measuring with y-axis. So in projectile motion, normally we measure angle with x-axis. Here we are measuring with y-axis. What angle again? This is the velocity, the direction of the strokes made by the man. Where the man will seem to go from ground, that will be decided by water's velocity also. So water's velocity could be till here, till here, till here, we don't know. So let's say this is water's velocity. Of course, the flow will be this way only, no? So resultant of these two will be where? It could be here, it could be here, it could be here. It can be here also if this is much bigger than this. Correct? So resultant of these two, which is this, can be anywhere. Now tell me, what is the x component of man's velocity? This is x component of man's velocity. I am not writing Vmx. I can write, but I just thought of writing Vx. Will you remember? So what is x component of man's velocity? Well, x component of man's velocity will be x component of this plus x component of this, if they are in same direction. So let's check. Vw is already along x. Vmw is at an angle. So what shall I do? Take components. So this is Vmw cos theta. This is Vmw sin theta. By the way, that day also I asked you, out of these three velocities, which one is controlled only by the muscles of the man? Vm or Vmw? Vmw. In still water, how much you can move, that is controlled by you in still water. That's why competitions are done in still water. In swimming pool they do competition. That will decide your actual training and your ability. So what will be x component of this man's velocity? This is this side, this is this side. Then what is the total velocity man will have along x? Assuming, let us say, Vw is more. Vw minus Vmw sin theta. Will you remember this result? Otherwise also you can draw diagram and create again if you forgot. What about man's velocity along y? Well, along y only this velocity is contributing. So Vmw cos theta. That's it. Once you know this, then you can ask. If they ask you, find time taken to cross the river. So they have to give you the width of the river. Let's say this is W. What is W? Width of the river. Or let me write small d. So this is width of the river. Now I don't know where the man will reach ultimately after crossing the river. That depends on, see students, because this velocity will always be there. 100% he will reach here. 100% he will reach here. Because of this velocity, pakka he will be going this way. But these two velocities are there which will decide whether he will reach here or maybe here itself. These two velocities will decide. Matlab this velocity will decide. So let us assume this velocity is more than this component. Then where will you reach after crossing? Somewhere here or somewhere here? If this velocity is more than this, you will reach somewhere here or somewhere here? Somewhere here. So let's say you reached here. So according to ground people, you went this way. This is whose velocity? Man's velocity in ground frame. Don't confuse with these two velocity. If you add these two, you will get this. And this is your S, this is your SY, this is your SX. This is called the width of the river and this is called drift. What is this called? Drift. Drift means how much you went along x-axis or along the flow when you cross the river. So by the time you cross the river, how much you moved along the flow. starting from this line, how much you went here. That is called drift. Obviously, it is the x component of displacement. Now, as I told you, here there is no acceleration. So, you can easily use S equals to ut. No need to write half at square. So, using Sy equals to Vyt. Vyt matlab what? Man's velocity along y. These are the man's velocities, yes or no? These are what? Components of man's velocity. Components of man's velocity. These two. So what is Vy? What is Sy first you tell? D. What is Vy? Man's component here. Vmw cos theta. Vmw cos theta into T. So from here T you can calculate. So this is one thing they can ask. Time taken to cross the river. If the person swims at what angle? Theta angle from the normal, or 90 plus theta from the flow. And what if they ask drift? Drift is Sx. What is Sx? Vxt. Time will be same time. You don't take components. So what is Vx? Vw was taking it this side. Vmw sin theta was this side. So minus Vmw sin theta, and T you know is this. So you can substitute this T if you want. So this is the theory. By the way, what if the man goes this way? Then what will be man's velocity from ground? Vmw plus Vw, because these two will be in same direction. That is called with the flow. What if the man comes this way? Then his velocity will be Vw minus Vmw. Now here there are few important cases that we must first discuss. First case is you want to cross the river in such a way that you reach directly opposite point. You want to cross the river in such a way that you reach directly opposite point. That is called crossing the river in shortest route. Crossing the river in shortest distance from ground frame. So this is the river. I want to start from here and I want to go like this when you people will see me. So I should go directly opposite point. Now if river was not flowing, obviously I will walk like this or I will swim like this, that everybody knows. In road, if somebody says cross the road like this, you will walk like this only because road doesn't move. But this is not road, this is river. So river is also flowing. So if you think, okay, I'll go here, I will stroke if I stroke this way, if I swim this way, then river velocity will add. So resultant will be here. So I will go somewhere here if I swim this way. So where I should swim? Somewhere here. So that angle they will ask. Or sometimes they will give the angle, they will ask velocity of water. So let's say you have to swim at this angle. So this is your velocity if water was not moving. So this is your velocity in still water which you will control. At what angle you are swimming? Some random angle theta. Now if you want to reach opposite point, then this angle should be such that when you add the river velocity, your resultant velocity should be here. So this is your man's velocity. I could have added here, but if you add here exactly, you will know how much to add. Triangle law is better here than parallelogram law. So the angle at which you should swim so that you reach opposite point is sin theta equals to opposite by hypotenuse. So Vw by Vmw. Time of crossing if they ask, width of the river means Sy. Yes or no? So Sy divided by Vy. Now man's velocity in this direction is Vm itself. So either you can add Vm or you can write Vm can be written Vmw cos theta. In fact, this was the one which I wrote, I think. But in this particular example, Vmw cos theta itself is Vm. Are cos theta you take, no, Vm by Vmw. What will be drift in this example? In this example, drift will be 0. And at what angle you have to swim? Vw by Vmw. But again, it is with respect to normal. From here, if they ask, please add 90 plus theta. Don't forget this part. Students miss this part sometimes. So you have to read the question carefully. So here no drift, but this is a very important condition for this to happen. So for this to happen means for drift to be 0, it is compulsory that Vw must be less than Vmw. Otherwise this will become greater than 1. Hypotenuse has to be more than opposite side. Simple. So this Vw has to be what? Less. Matlab river velocity has to be less than man's velocity in still water. That makes sense also. If tsunami is coming, you will reach opposite point. How? Your velocity will never be greater than Vw. So your velocity will never be greater than Vw. You will never reach opposite point. So if Vmw is less than Vw, then drift cannot be 0. That to pakka we understood. Water velocity is too high than your velocity in water. So now drift cannot be 0. So question is, for what theta drift will be minimum? 0 you cannot make, drift you cannot make 0. At least you have to try to make it minimum. So for that what we will do? We will write the drift formula. What was drift formula? Sx Vxt. What is Vx? Vw minus Vmw sine theta. Not this case. Don't see this case. Here to I reach opposite point. You have to see the general case. General case was what? Vmw had one component here, Vmw sine theta, opposite to Vw. So your resultant velocity along x is this. Just 5 minutes back I did. Into t. What was t? You check. D by Vmw cos theta. Right or not? So this is your drift. Let us call this drift as d. Now you want this drift to be what? Minimum. So when a function has to be minimum, in calculus what do we learn? If a function has to be minimum or actually maximum also, then what did we learn in calculus? Maxima minima concept. Differentiation of the function should be 0. So for this to happen, d by d what should be 0? Who is the variable here? Who is the variable here? River velocity will change. Yamuna ji, please move faster. Ganga, move faster. No, Vw you can't do anything. Width of the river you will change. Width of the river. Vmw, suddenly you become strong. 1 year afterwards, if you come, you may be stronger by training and all. Now I am going to cross. Now how I will become stronger. So the only thing I can change is theta. Where I can swim, that is under my control. So it is. So the variable is theta. So here you will get what? Theta is in numerator and denominator. So you have to use what formula? U by V. Ratio formula. Solve it. I will not solve obviously. If you solve, you will get sine theta equals to. Very simple, students. Here who is less? Put Vmw in numerator. Finished. Matlab reciprocal of this. Makes sense also. Because sine theta cannot be greater than 1. But please do this exercise. By the way, this sine theta you can put here now to find the minimum drift. How do you do calculus, ma? If they give a function and they ask you to find the minimum value of the function, first you take differentiation, put equal to 0. Whatever x you get, put that x back in that function. So put this sine theta back here. Sir, cos theta is also there. What are you saying? Cos theta is root over 1 minus sine square theta. Finished. So this is the case 1. Now case 2 is shortest time. So you want to cross the river in shortest time. At what angle you should swim? So if you swim at this angle, what was the time taken to cross the river? First, d by which component will take you here? VMW cos theta. River will have no role. River is only taking you here and there. I mean here. So VMW cos theta. Now you want this time to be what? Minimum. So if you want time to be minimum, this cos theta should be maximum. So theta should be what? 0 degree. That means you should not swim here, you should swim here. So therefore, for minimum time, you have to swim here. That means at theta equal to 0 degree. Which means you will never reach here. Because now river velocity will add and you will go somewhere here. So this will be your drift. By the way, what is the minimum time taken if they ask? Minimum time taken. D by VMW. And what is the drift if they ask? Here what is Vx? Only VW. Because theta is 0. Otherwise put theta 0 here. Put theta 0 here. What will happen? This will become 0. This will become 1. So what is D formula? Vx into T. Who is Vx now? VW. Who is T? D by VMW. Correct, students? Of course, you will get same answer if you use direct formula. Just put theta 0 because to cross the river in shortest time, I have to cross this way. I have to swim this way. Question number 124. A man crosses a 320 meter wide river. So there is a river which is 320 meter wide. Who is this? Small d. Such that it moves perpendicular to the current. So the person moves perpendicular to current. Now there is confusion. Is he swimming perpendicular to current or ground people are seeing he is going perpendicular? So you have to read the question carefully. Moves perpendicular to current as seen from ground. That means clearly he must be going somewhere here, right? He must be going here so that this velocity will be added with river velocity. Then ground people will see he will go here, isn't it? So this is your man's velocity from ground frame. This is from ground frame. And he took how many minutes? 4 minutes to reach the other side. If in still water, that means VMW, in still water, he can swim with a speed equals to 5 by 3 times current. Current matlab VW. Find the speed of the current, matlab VW. Okay. So from this T and from this D, we can calculate y component of man's velocity. So Sy is equals to Vyt. Who is Sy? 320. This is your D, no? Vy. VMW cos theta, but that is Vm also. I told you in this particular example where ground people see him going here. That means VMW cos theta. Actually Vy is VMW cos theta. If you remember. Yes or no, students? This formula how many times we have written? T is equals to D by VmW cos theta. But if you look carefully, who is VmW cos theta? VmW cos theta is Vm itself. VmW cos theta is nothing but Vm. So from here what you will get? Vm. What is D? 320. What is time taken? 4 minutes. So this is 80 meter per minute. Answer is in meter per minute, so keep it as it is. Now this is given. They want VW. Now from this right angle triangle, we can use Pythagoras theorem. So what will be VmW square? VW square plus Vm square. Since we want VW, let us substitute for VmW. What is VmW? 5 by 3. So 25 by 9 VW square, right? Equals to VW square plus Vm square. Bring VW square this side. 25 minus 1. 25 by 9 minus 1, sorry. VW square equals to Vm square. 16 by 9, take square root. 4 by 3 VW equals to Vm. So what will be VW? 3 Vm by 4. How much was man's velocity already we found? How much was man's velocity already we found? 80 by 4. So what is the answer? 60 meter per minute. Students, please understand, the hypotenuse will change depending on the different cases. In this case, who is hypotenuse? VMW. Because ground people should see he going directly opposite point, perpendicular to flow. But suppose they say man wants to cross the river in shortest time, then you know what should be theta? 0. So how he should cut the water flow? This way. Then river velocity will add. Then this will be your man's velocity from ground. So now who is hypotenuse? Vm. So that will keep changing based on different cases, and sometimes you will not get right angle triangle only. When it is general case where the man is going somewhere here, river velocity is somewhere here, then your velocity from ground will be here. So now you cannot use, now there is no hypotenuse only. So please understand the question and then solve it. Okay, 124 we did. 125 you see. A person aiming to reach exactly opposite point on the bank. I think you understood what you have to do now. So he is aiming to reach exactly opposite point with a speed of 0.5 meter per second. They must mention in still water, students, otherwise students may have some confusion. So this speed that they have given has to be somewhere here, isn't it? Because he wants to reach here with the flow. So he has to swim in this direction, which is given 0.5, though they didn't mention very clearly. At 120 degree with the flow of water. 120 degree with the flow means this one, because flow will be this side, yes or no? And if you want to reach here, how much river velocity should add? This much, exactly. Then this will be your actual velocity from ground frame. Again, there is nothing actual about this, right? For every observer, whatever he sees is actual. So if this is 120, what is this? 30. So directly sin 30 formula. Those who remembers, you can use directly also. Sin theta formula was VW by VMW. So if you remember, directly VW by VMW. Sin 30 is half. VW we have to find. Man's velocity in still water, like that they should have mentioned, is 0.5. So if you cross multiply, 0.25. So velocity of water is 0.25. (126). The speed of a boat is 5 km per hour in still water. So this is very clear now. VBW is 5 kilometer per hour. B I am using, so we are replacing the man by the boat. It crosses a river of width. It crosses a river of width 1 kilometer along the shortest possible path. Same story. If you want to cross in shortest path, you have to swim at that angle where this much will add from water's velocity and you will go this way. So again same story, students. Achha, M I wrote. So let me just replace B by M. Think boat is man. The velocity of river, it crosses in how much minute they told? 15 minutes. I think this question similar we have done. So from these two data, what you can calculate? Vm you can calculate, right? So this velocity, actually we should use Vmw cos theta, but Vmw cos theta is Vm, yes or no? So Sy is equals to man's velocity along y is Vm itself into T. So what formula I use? D equals to Vmw cos theta into T. But Vmw cos theta is Vm. So what is Vm? 1 kilometer by 15 by 60 hours. So 4 kilometer per hour. So Vm I got, Vmw they have given, so Vw I can use directly Pythagoras theorem, isn't it? So what will be Vw? Under root Vmw square minus Vm square. This is from Pythagoras theorem applied to this velocity diagram. What is Vmw was given? 5. This is 4. So what is the answer? 3. Any confusion or understanding? 127 has both cases in the same question. Please understand. A man wishes to cross a river in a boat. If he crosses the river in minimum time, he takes 8 minutes. So minimum time 8 or 10? 10 minutes. So for this case, we know how he should swim. He should swim perpendicular to flow. So river velocity will add and he will go with man's total velocity will be here, somewhere here he will go. This is the case for minimum time, we know already. That's why theory we have to do first. Problem solving becomes easier. And the drift of how much happened? 120. So from here immediately what we can find? What is this drift? Sx. Who takes him here? Man's x component of velocity. Who is man's x component of velocity? Vw. Yes or no? Because Vm vector is Vmw vector plus Vw vector. So in this diagram, this has y component this, x component this. But sir, we remember you wrote Vmw cos theta and all. That was when he swims at this angle. So when the man swims at this angle, Vmw cos theta was y component. Check the notes. What was Vx? Vw minus Vmw sin theta. What was Vy? Vmw cos theta. Correct? In our theory. To cross in minimum time, at what angle he should swim, I told. At what angle he should, this is the angle, this is the vector representing his strokes in water. When a person in the bus walks like this, that is his walking which in the bus with respect to bus. So this is man's velocity in water. What is the angle at which he is swimming? With the normal 0 degree. Don't measure this theta, Baba. this one. With normal, he was going at this angle in this theory. To cross in minimum time, he should swim at theta 0 angle. Put theta 0. This will become 0. This will become 1. So Vx will be what? Vw. Vy will be what? Vmw. That's what I am saying. So what will be your Sx? D. Vx into T. What is D? 120. Who is Vx? Vw. What is time taken? 10 minutes. So what is Vw? 112 meter per minute. If he crosses the river taking shortest time, in case 2, he crosses the river in what time now? Shortest time means shortest route. Then he has to swim at this angle. This will be Vw. This will be the man's velocity. Correct? So he will cross the river like this from ground frame. This time how much time he took? 12.5 minutes. What they want? Velocity of man, I mean boat matlab for us, man with respect to water means in still water. So we are supposed to calculate in this problem Vmw. Now students, tell me one thing. In these two cases, which velocities are same? Vw will be same. River velocity you cannot change. What else will be same or not same? Anything else will be same or not same? What about Vmw? Same boat or same man? Same or different? Same. In case of boat, it is the engine that will decide. Vmw. So Vmw also has to be same, the length I mean, not the direction. That depends on his strokes or where you row the boat. So Vmw has to be same. So what will change in these two diagram? Vm. Because theta changes, so Vm changes. So better to put Vm dash here. Okay. Also, width of the river also will be same. Width of the river also will be same. So let us try to relate that. So this D in this problem is what? Sy. Sy is what? Vyt. What is Vy in this particular case? Vmw. So D is Vmw into T. And T here was T minimum. So D is Vmw into 10 minutes. Let us try to calculate D here also. So D here will be what? Vmw cos theta, which is Vm dash. Yes or no? So this is Vm dash into T. And what is T? In the second case, 12.5. Both are minutes. So from equation 2 and 3, I can write Vmw into 10 is equals to Vm dash into 12.5. Remember, my aim is to find Vmw. So Vm dash will be what from here? 100 by 125 into Vmw. How much it will be? Huh? 0.8 means 10 by 8, 5 by 4. Right? 4 by 5. So 4 by 5 Vmw. Okay, students. And this Vw which I measured is same as this Vw. So Vw already I know. Vm dash I know in terms of Vmw. So here if I use Pythagoras theorem, I will get Vmw. From second figure, we can write Vmw square is equals to Vw square plus Vm square. Vm dash. Vmw we have to calculate. VW we found 12 plus Vm dash we found 4 by 5, so 16 by 25 VMW square, right? And this is 144. This you bring this side, it will be 1 minus 16 by 25 VMW square equals to 144. This will be 9 by 25. Take square root. 3 VMW by 5 equals to 12. 3 4s are 12, 5 4s are 20. So VMW will be 20. Unit was kept meter per minute. So these are some easy level questions. Let us now do little higher level questions. So I hope you guys understood what Lekhia is saying. She is saying that why don't you put theta here, and you already found Vm dash by Vmw. So this is adjacent by hypotenuse. So this is your cos. So cos theta you already got 4 by 5 because cos theta is Vm dash by Vmw. Once you got cos theta 4 by 5, sin theta will be what? 3 by 5. And in this diagram sin theta will be Vw by Vmw. And Vw we found 12. So this way also you can do. Same answer you get, no? Yeah. Yeah, that is also good actually. Okay. Now we will do some different unique questions in this topic. So why should I cross the river always perpendicular, or why I want to reach always opposite point? Let's say there is a river like this. I want to start from here and my friend is actually here. So I want to make sure I reach there. I should not reach here, I should not reach here. Okay, so 30 degree. So I must reach from A to B. And let's say A to B is 100 meter. Water's velocity is, let's say, 4 meter per second. Water's velocity will be obviously along the river. Question is, where should man swim? So you should find man's velocity. Okay, in still water I will give you, it is, let's say, 3 meter per second, or let's say 2 meter per second in still water. And question is, at what angle he should swim? Now they can ask with this line, they can ask with river flow, but even if they ask with river flow, first you calculate with respect to this line, then add 30 degree. What is there? Like in the previous question, when they asked at what angle you should swim so that you reach here, we measured this angle first, then we added 90 degree. Only difference is this line now I have converted to this line, that's it. Understood? So question is, at what angle he should swim. Don't draw perpendicular, then you already know the angle, 60 degree. So don't draw perpendicular, we don't know the angle. So at what angle he should swim so that he can cross the river from A to B. So Vm, the man's velocity from ground, should be from A to B. So can you guess what we should do? Simple, you just have to consider here x now. That's it. And automatically if you consider there x, this will be what? Y. And if you want to move only along x, if your resultant velocity, this is resultant velocity, Vm vector is what? Vmw plus Vw. So if the sum of this and this should be exactly here, then it means there should be no velocity here. That means component of Vw here and component of Vmw here should cancel each other. Now if this is 30, VW will have one component here, VW cos 30 here, VW sin 30. And if this is VMW at theta, this will be VMW cos theta, this will be VMW sin theta. So for the man to go exactly here, what should happen? VMW sin theta should cancel VW sin 30. Everybody understood the story? That's how you have to do. It is very same to, if you want to reach opposite point, then what I told, you have to swim at what angle? VW by VMW. Why? Because this VMW will have one component here, and VW has here. So these two should cancel. And for those two should cancel, to cancel, VMW sin theta should be VW. So what will be sin theta? VW by VMW. That is how we could have derived that result also. Okay, what is VMW given? 2 sin theta. I hope I will not get sin theta greater than 1. Then problem. VW 4 sin 30 half. Ooh, almost. So sin theta equals to 1. Theta equals to theta 90 means I should swim here, right? Theta is measured from this line. So theta 90 means with river flow how much? 120 with river flow. With flow. Acha, they can ask you time taken to reach cross. What will you do? Time taken to cross. AB distance they have given. Now you find speed in this direction. What is speed in this direction? VMW cos theta plus VW cos 30. Correct or not? What is the total velocity man has along x-axis? Component of this, component of this. These two components should cancel. These two components should add and take him here. So this component will be VMW cos theta, and VW's component here will be VW cos 30. And sin theta is 1, so cos theta will be 90, cos 90 will be 0. Wow, nice, this is 0. So AB is how much? 100 meter. VW is how much? VW 4 cos 30 root 3 by 2. So 200 by root 3 seconds. Sorry, 425 so 50 by root 3 seconds. Okay. So the next question is, again you want to cross a river. So a man crosses the river from A to B, okay, directly from A to B like this time also at 30 degree. Twice. He crosses the river twice. First time he took time 2 minutes. Second time he took 4 minutes. Very interesting. How there are 2 times, sir? According to our calculation, there was only 1 time. VMW, man's velocity in still water, is given root 3. You have to find velocity of water. Okay, let's start. I think few things you must have understood by now. In order to reach directly here, I must call this one as x, then velocity here should be 0. Now water velocity here is VW. So this will be VW. Let me write down. VW cos 30. This will be VW sin 30. Yes or no? And man, I don't know is going in what direction with respect to water. But wherever he is going, that will have two components. One here, VMW X, and here VMW Y. So students, in such cases, no, if you can, better to write for this velocity as u something, u. Then this will be ux, uy. But you need to remember that u is VMW. If you write VMW, you will always know it is velocity of man with respect to water. Because you have to write three symbols here. And you have to simplify a lot. So now, to reach this way, what is important? To go from A to B directly, what I told. The y component of man's velocity in water should cancel. VW sin 30 means half. Yes or no? This can be written VW by 2. And time taken they told. What is time taken they told? 2 minutes. So 2 in minutes will be what? This distance which they have not given divided by what is the total speed of man in this direction? VMW x plus VW cos 30. Cos 30 means how much? Root 3 by 2. Equation 2. 1 unknown, 2 unknown, 3 unknown, 4. Right now 4 unknown we have. So we need minimum 4 equations. 2 we have here. That other 2 will come from here. Now my question is, what is this time? This is also time taken from A to B they told. But how? Already when he goes this way, he takes 2 minutes. Then how come he will again take 4 minutes? Huh? No, this is going A to B. He is crossing it twice. No. Hey, he didn't say A to B 2 minutes, B to A 4 minutes. He didn't say. A to B, B to A, didn't say. A to B twice. Can you guess? Just now I told not that one, bro. Not B to A. A to B, it took 2 minutes. Again A to B, how it will take different time? That too more. How? He has to change theta. Very good. Because there will be one more theta, reverse of this theta. Let me try to explain with diagram. This is very interesting question, guys. So this is your river. You want to go from where to where? Case 2, A to B. At what angle? 30. River velocity we cannot change. Man's velocity in water also we cannot change in magnitude. But angle we can change. Now you can adjust your angle in such a way that VMWX is here. But VMWY should be here only. Matlab, I don't know you guys understood or not. This should be there. Of course this should be there because man has to go this way. So this water velocity already has two components here, isn't it? VW root 3 by 2, VW half. That too is same, no students? So you need this velocity of man with respect to water to cancel this. And he can still go here. If this is greater than this, but he will take more time. So what will be VMWY? VW by 2 now also. That means this VMWY and this VMWY are same. And time taken will be what this time? What is time taken from here to here? How much? 4. And what is time taken? Distance is what? Same distance. What is the speed in this direction? VW root 3 by 2 minus VMW x. Who gave me the right to assume this in magnitude is same as this? Why these two are same in magnitude? Because these two are same in magnitude and VMW is also same in magnitude, only direction is different. So therefore VMW x also has to be same. Students, if A is same, AX is same, then AY has to be same, because A is what? Under root AX square plus AY square. VMW will be same, I told you, man suddenly cannot become very strong. So VMW is going to be same. VMW y has to be same here and here, because in both cases you have to cancel VW by 2. So VMW x has to be same, only difference is what? Theta, direction. Understood? So now from equation 4 and 2 we can simplify to find some relation between VW and VMW x. Okay guys, let's, what to do with these two? Divide. So equation 4 divided by equation 2. On the left side, 4 by 2, 2 I will get. Right, 4 divided by 2. On the right side, AB will cancel. This will go in the, this will be in denominator, because I am dividing equation 4 by 2. So this will be in denominator. So VW root 3 by 2 minus VMW x. And this will go in numerator, VMW x plus VW root 3 by 2. Cross multiply 2 into this, VW root 3, 2 into this, minus 2 VMW x component. That side, VMW x plus VW root 3 by 2. Take minus 2 VMW x that side, it will become 3 VMW x. Bring this one this side. You will get VW root 3 minus root 3 by 2, which will be VW 2 root 3 minus root 3, 1 root 3 equals to 3 VMW x. So what will be VMW x finally in terms of VW? This 3 you bring here, so 1 by 2 VW 2 root 3. Am I right? So I got VMW x. VMW y already I know. VMW y already I know. So now I will write the magnitude of any vector. How do you write VMW? Under root VMW square plus VMW x square VMW y square. Why I wrote under root? I will write square both sides. Oh no, we are supposed to find VMW only, right? VW, okay. Should I put under root or not? Let me keep it square here, no problem. So VMW square will be, what is VMW x square? VW square by 4 into 3, 12. If you square this, plus VMW y square is VW square by 4. That will give you 12. 1s are 4, 3s are 3 plus 1, 4. So 1 by 3 VW square is VMW square. Out of these two, who is given? Now finally you tell me. VMW is given. How much? So root 3 square is equals to VW square by 3. So what is VW? 3. Right? Root 3 square is 3. 3 cross multiply with 3 is 9. Square root of 9 is 3. Question number 159, you check. It says the flow speed of water varies with distance from its bank as V equals to root Z. So here V is velocity of flow of water. So VW is under root Z. Where Z is what? Perpendicular distance in meters from the bank. So imagine this is your river and this is one of the banks. As you move perpendicular to this flow, this is your Z, they told. So as you move along this Z, because they told Z is where? Z is the perpendicular distance from the bank. So as you move perpendicular to flow of water, your Z should increase. Accordingly, your VW will also increase. So this is unlike our previous questions where VW was fixed. Here what is happening? Near the bank, flow velocity is very less, 0. Z 0, VW 0. As you go this way, Z increases, VW increases. So they are asking you, a swimmer or a man enters the river at point A. Let's say here he enters point A, origin, and swims at 2 meter per second. Again, they should have told in still water. So he swims at speed 2 meter per second. This is man's velocity in water. 2 meter per second. Sir, how did you know it is normal to the current? How did you know it's normal to the flow? In the question they told normal to the flow. What is his drift downstream by the time he crosses the river, or by the time his normal distance becomes 2 meter? Normal distance matlab this Z. So by the time the Z becomes 2 meter, how much is the drift? That they are asking. So let's say this is your Z equals to 2 meter. To make things simple, this is Z equal to 0. So this distance is your 2 meter, like your width of the river. Clear? So by the time you reach Z equals to 2 meter, how much will be your drift, they are asking. Question, do you think will you go straight? No. Why? Look here. Before you were going with VMW, river velocity this much was adding, you went here. Correct? Then you will try to go here. Your velocity is always this way. River velocity same will act. Again you will go here. So this keeps happening, right? So that's why ground people will see you going always here. But here the problem is what? This speed of water, the flow velocity keeps increasing with Z. So initially if it is this much, afterwards it is this much, afterwards it is this much. So what happens? You go in a curved path. So you will go somewhere here like this. Okay. So let's say you have reached some point here at time t. This is time 0. This is time taken to cross, let's say capital T. At time t you are here. That time what is your coordinate? This will be x comma z. Okay. When you are here, you are flowing, you want to swim this way. That is fixed. And here there is what velocity? River velocity. This is which coordinate? X comma z. If you want you can call it y, but you have to change the question also. So now can you tell me who is responsible to change my x here? Dx by dt is due to, dx by dt is what? Vx, man's velocity along x. Who is that velocity? Vx in this picture, my x coordinate is changing due to whose velocity? VW or VMW? VMW has no role here because I am swimming always perpendicular to flow. So this is nothing but VW. VW is given root Z. Yes or no? Root Z. Similarly, tell me Vy. Dy by dt. Not dy, sorry. Vz. Dz by dt. Who is changing my z coordinate? Which velocity? River has no role. VMW. Now VMW is fixed. So dz by dt will be what? 2. So how to solve equation 1 and 2? By the way, if they ask time taken, here only cross multiply, integrate. You will get z equals to 2t. Z is given 2 meter. So 2 equals to 2t. So t equals to 1 second. So in 1 second I will be here. But they did not ask time. They want to know this drift, which is, if you look carefully, the final x coordinate. Final meaning by the time you reach z equals to 2 meter. So can you tell me how this one I cannot solve? No, because this has 3 variables, bro. How do I solve this? So can you tell me how can I solve these 2 equations? In maths they may have told you parametric. But what I should do to these 2? You tell me just. Divide those 2. Best is divide those 2. So let me divide equation 2 by equation 1. What will I get? Dz by dx is equals to 2 divided by root z. So if you cross multiply, you will get root z dz is equals to 2 dx. Then integrate. When you started, x was 0, z was 0. Yeah. When you started, x was 0, z was 0. When you reached here, x we want to calculate, and z became how much? 2. Correct? What is integration of root z? Z power half. Half plus 1 by half plus 1. Z power 3 by 2 by 3 by 2. Put upper limit 2 power 3 by 2 by 3 by 2. Yes or no? Lower limit is 0. And this is equal to 2d. This 2 will go up, cancel with this 2. First you take these 2 up, then cancel with this 2. So what is d? 2 root 2 by 3 meters. This is 2 root 2. 8 power half. 8 power half. Understood?